Lesson 11.9, Multiple Slit Diffraction. Diffraction grating, usually it's what it's called, is an arrangement of many closely spaced slits, as many as 40,000 slits per centimeter, and it produces interference patterns, just like the double slit did. Light rays are essentially parallel. The principal maxima occur when the light from one slit travels whole wavelengths more to meet light from a second slit, producing constructive interference. Otherwise, you get destructive interference. The principal maxima then are, oh wait, that looks the same as yesterday's. Wow. A laser which produces 650 nanometer light shines through a diffraction grating. An interference pattern is produced on a screen 50 centimeters away. The distance on the screen between the second order maxima and the center is 13.5 centimeters. What is the slit separation of the grating? All right, so let's draw a picture. My laser is down at the pointy end. That's the screen. So this is my laser. Let's try that again. Laser, and this is the screen. It's 50 centimeters away. All right, we could use tangent and we could find our angle using our tangent. And we get our angle to be about 15.11 degrees. So that is our angle here, theta. That is also the angle used in the formula to find wavelength and things. And so we can use the 15.11. We have our wavelength there. We have our, it's second order, so that means m equals 2. And fill those in. Remember, nano is times 10 to the negative 9. Multiply by d and divide by, multiply by d. Divide by sine of 15. With the calculator. And the slit separation is 4.99 times 10 to the negative 6 meters, or approximately 5 micrometers. Now, diffraction gratings produce narrower, more defined maxima, but a small secondary maxima between. So, the diffraction grating, you end up with a point and a point and a point. Whereas the double slit, it was you had a point, 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 kind of went, and then it went like that with little bright spots. So it's different. You had, for the diffraction grating, you have just very distinct points. Double slit, you have these wide bands. Diffraction gratings can be used to split colors. Each color of light is a different wavelength, so each color bends at a different angle. Which one appears to bend the most? Well, looking at the picture, red appears to bend the most, and violet appears to bend the least. So, application of diffraction gratings. Each element in a hot gas emits or absorbs certain wavelengths of light. By using a diffraction grating, the light can be split and the wavelengths measured. The convenient thing about using a diffraction grating instead of a lens is that the diffraction grating is very thin. It's like a thin piece of plastic. And here's two different elements. The top one's neon, the bottom one's helium, or hydrogen, sorry, hydrogen. And by looking at where those bands, the dark bands are, the bright bands are, you can figure out what elements are present in stars. So they know, this star contains iron, or this star contains lots and lots of helium. That is also how they know that the universe is moving apart, because stars in distant galaxies show Doppler shift. All the bands are shifted down in wavelength from where they should be on the spectrum, And so from that shift, you can calculate the speed that they're moving away from us. Enjoy.